in this video, we're going to talk about normal distribution. So what is it? Normal distribution is also called a bell curve, and we are going to use it to analyze data. So that means we're going to look at the mean of our data, and then we use standard deviation to look at the different amounts or different values for your data for each standard number of standard deviations away. So, and we're going to use that to solve problems that we are given. So I put a copy of the standard normal distribution curve, also called the bell curve, here so we can kind of look at it. So I'm going to zoom this in a little bit. So right here, this line right in the middle, the top of the curve, is going to be your mean, which is your average. And then what we do is we calculate the standard deviation, and then if I move one standard deviation away, I know that 34% of my data is going to be one standard deviation above, and then 34% of my data is going to be one standard deviation below, okay? And then if I go 2 standard deviations away, if I go 2 standard deviations above, or over here, this will be a little harder to see, 2 standard deviations below. So it's kind of, I think, a little bit difficult to understand what that means. So I wanted to just do an example so that I could put some numbers with it, because I think it's hard to process. We'll just move 1 standard deviation up and then see what that means. So let's put some numbers with it to try and make a little bit more sense out of how a bell curve works and how to use those percentages to help you solve problems. So this problem says Jim Snow pays for shipping for his trees based on the tree weight. Okay, so he's a tree shipper. He knows that the weight is normally distributed, so he can use the standard normal distribution. He decides to weigh 1,000 trees randomly in his next shipment. He calculated the mean and standard deviation of their weights to be 30 pounds and 10 pounds respectively. So what that means is they listed mean and then standard deviation. So when they use the word respectively, it means the first word goes with the first number, and the second number goes with standard deviation. So that means that the mean is 30 pounds and the standard deviation is 10 pounds. Jim uses the normal distribution curve to calculate the number of trees in each segment of the distribution. Okay, so if I use the normal distribution curve, it tells me that the mean is 30. So I'm going to come up here and I'm going to draw. The mean is 30 pounds. Now it tells me that my standard deviation is 10. So that means 10 pounds from the mean. So if I move up 1 standard deviation, I have to move up 10. So here would be 40 pounds. Here would be 50 pounds. And here would be 60 pounds. Okay. 1 standard deviation below the mean, so I'm going to subtract 10. So this is going to be 20 pounds. This is going to be 10 pounds. And this would be 0 pounds. Okay. So what we're going to do is we're going to use this data to help answer the question. So I want to know, out of the 1,000 trees, how many of the trees weigh between 30 and 40 pounds? Okay, well, between 30 and 40 pounds, we're looking here at this 34%. We're 1 standard deviation above the mean. So this kind of bluey area. So I know that 34% out of my 1,000 trees are going to weigh 30 to 40 pounds. So to mathematically figure that out, I take 34%, which is, as a decimal, 0.34 times 1,000. Gives me 340 trees. Okay, next, I want to know how many trees are going to weigh between 40 and 50 pounds. Okay, well, 40 and 50 pounds, that's this kind of pinky part right here. So this says between 40 and 50 pounds is going to be 13.5% of my trees. So 13.5% as a decimal is 0.135 multiplied by 1,000 gives me 135 trees. Okay, and last, how many trees weigh between 50 and 60 pounds? Between 50 and 60 pounds is this section right here, and it tells me that it's 2.35%. So 2.35 is 0.0235 times 1,000. Gives me 23.5 trees. Well, you can't really have 23.5 trees, so we can round it up to 24, because you can't really have half a tree. All right, now we just took care of this half of the bell curve. So if I'm looking at it, would it make sense that we have that gives you half of the trees? So if I looked at what's 340 plus 135 plus 24, this gives you 499 trees. So you might say, well, why doesn't it equal 500? Well, because there's this one up here that we didn't look at, it didn't ask us for. Between 60 and 70 pounds, there's 0.15%. So there's going to be that one tree that weighs between 60 and 70 pounds. But so now I'm looking at this and I say, okay, well, it makes sense that I have 500 trees that are in this upper half because I have total 1,000 trees, and I have 500 trees that are below this half also. So I could also answer another question. How many trees weigh between, here, let's look at here. What if I said how many trees weigh between 10 and 20 pounds? Well, we know that's 13.5%, which we already figured out is 135 trees. So that's how you use a bell curve or a standard normal distribution curve in order to analyze data from a mean and a standard deviation. So let me know if you have any questions. Good luck.